Welcome to the last part, which is part 3, expectation and variance of function of random variables. So now we're going to learn about expectation of function of random variables. A is for discrete random variables. Number 1, expectation or the expected value of a random variable x is mean of x. And is denoted by capital EX. If x is a discrete random variable with probability distribution function Px equal to x, then expectation of x equal to summation of x multiplied with probability of x. So in other words, expectation or expected value is actually the mean of x. Number 3, if gx is a function of a discrete random variable x, then the expectation of gx is defined as follows. Expected value of gx equal to summation of gx multiplied with px. Number 4, for expectation of x squared is equal to summation of x squared multiplied with probability of x. And number 5, for a and b constants, we will have expectation of ax equal to a multiplied with expectation x. And for expectation ax plus b, we will have a multiplied with expectation x plus b. Example 1, the probability distribution of a discrete random variable x is given as follows. So this is the PDF in table form. Now we need to calculate the expectation of x. So remember the formula given previously. Expectation of x is equal to summation of x multiplied with the probability of x for all x. So now we have our x value is 1. We will multiply it with the probability, which is 0.1. Then plus the x value of 2 with the probability of 0.3, and so on until 5 times 0.1. Then you will get the expectation of x equal to 2.9. Example 2, the probability distribution of a discrete random variable x is given in the table below. So we have x value 1, 2, and 3. Find a, b, c, d, e, and f. Let's see the solution. So this is the previous table given to us. A, you need to find the expectation of 2. So summation of 2 times px. So we will have all the probabilities in here multiplied with 2. So the first one will 2 multiplied with 1 over 6 plus 2 times 2 over 6 plus 2 times 3 over 6, then you get 2. So the expectation value of, the expectation of 2 equal to 2. B, expectation of x. So it is equal to summation of x multiplied with probability of x. So the x value, the first x value is 1. 1 will multiply with the probability, which is 1 over 6 equal, then you get 1 over 6. Then we're going to plus it with 2 times 2 over 6. And then plus 3 times 3 over 6. You will get 7 over 3. That is expectation x. How about expectation 5x? When we have expectation 5x, the 5, the constant, we will keep it outside. So 5 expectation of x. 5 will multiply with, we will multiply 5 with the expectation x that we obtained previously, which is 7 over 3. So we'll get 35 over 3. And D, expectation of 5x plus 2 is equal to any constant over here. You can keep it outside. So we have 5ex plus 2 and 5ex plus 2. This is the constant, it's just a constant, so we keep it as remain 2 over here. No need to put e at the front. So 5 multiplied with ex we obtained just now, plus 2. Then you get 41 over 3. And then we have to find expectation of x squared, which is equal to summation of x squared multiplied with probability of x. So the first x value is 1. 1 you need to square it. So we have 1 squared times with the probability 1 over 6 plus 2, this is 2 squared times with 2 over 6 plus 3 is 3 squared times 3 over 6. Then you get 6. And the last one is expectation of 5x squared plus 2. So 5 over here is a constant. We keep it outside. 5 expectation of x squared plus 2. This 2 is a constant. So just keep it over here plus 2. No need to add on ex at the front. So 5ex squared. 5 multiplied with ex squared that we obtain over here times with 6, then plus 2 you get 32. Example 3. X is a discrete random variable and given expectation of x equal to 5. Find expectation of 5x minus 4 and expectation of y if y equal to 3 over 2x minus 1. Okay, we are given expectation of x equal to 5. Now we will need to find expectation of 5x minus 4, where we can write it down in this way. 5 expectation x minus 4. So 5 will multiply with ex, where our ex is 5 minus 4. Then you get 21. And then b, given y equal to 3 over 2x minus 1 here. So expectation of y is equal to expectation of 3 over 2x minus 1. Since y over here is actually equal to 3 over 2x minus 1. So instead of using y, we're going to use this 3 over 2x minus 1 in here. So now we're going to simplify this part. Now you have 3 over 2 as the constant. So you will need to take it out. 3 over 2. Keep it the ex as the expectation and minus 1 is the constant. Just leave it as a constant, negative 1. So 3 over 2 multiply with expectation x, which is 21, minus 1, then you get 13 over 2. While this is variance of function of random variables, previously we learned about expectations. Then from the expectation, we're going to find the variance for the discrete random variable. First one, expectation x is equal to the mean of x, where expectation x equal to mu. Then variant x equal to expectation x minus mu square, where variant x equal to expectation x square minus expectation x the whole thing square. This part actually we obtain from this when we expand it. The first one we have this, then when we expand it, you will get this part. Number 2, important properties of variance. A, variance A, or A is constant equal to 0. Any constant, you will get the variance equal to 0. Then variant ax equal to a square variant x. The constant over here, you bring it outside. Then you square it. C variant ax plus b equal to a square variant x, where a and b are constants. Why does it b over here is missing? There's no longer b over here. Because b is a constant. Remember the first rule? If you have variant of b, then it will become 0 because b is a constant. So we don't have to write it down. Then number 3, the standard deviation of sigma equal to square root of variant x. Example 1. The probability distribution of discrete random variable x is given as follows as in the table. So now you need to find the expectation of x squared, and variant x. Expectation of x equal to summation of x times probability of x. So given these values, you're just going to multiply it and add up. 1 times 2 over 7 plus 2 times 4 over 7 plus 3 times 1 over 7. Then you get the expectation of x equal to 13 over 7. How about expectation x squared? So expectation x squared is equal to summation of x squared multiplied with probability of x. So all the x values over here, you will need to square it. First one is 1 square times 2 over 7, then plus 2 square times 4 over 7, then plus 3 square times 1 over 7. Then you get 27 over 7. And C, variance of x. Variance of x equal to expectation of x squared minus the whole thing of x squared. The whole thing of expectation x squared. So this is the formula given earlier. So this we have found this 27 over 7 minus 13 over 7, that is square. So at the end you get the variance equal to 20 over 49. Note first, the variance of x is always positive. So make sure you get a positive number for your variance. Otherwise, it will be wrong. Second one, the standard deviation of x is equal to square root of 20 over 49, which is equal to this. Example 2, the probability distribution function or PDF of a discrete random variable is given as follows. Again, we were given a table. So you need to find variant of x minus 2, variance of 2x plus 3, and variance of 5 minus 8x. So we first need to find expectation of x, because from the expectation, we will use it to find our variance. First, expectation of x equal to summation of x multiplied with probability of x. So again, you times it 1 times 1 over 6, 2 times 1 over 6 up until 4 times 3 over 16. Then you get 41 over 16. Then we're going to find expectation of x squared, which is equal to summation of x squared multiplied with probability of x. So the whole x values over here, you're gonna square it. Then you're gonna multiply it with the probability. So 1 square times 1 over 6 up until 4 square times 3 over 16. Then you get 117 over 16. So now we have expectation of x and expectation of x squared. We can find our variance. So variance of x is equal to expectation of x squared minus the whole thing of expectation x square. So we just substitute the value we found previously, then you get this value. How about variance of x minus 2? So remember, variance of x equal to variance of x. When we have variance of 2, 2 over here is constant, so you get 0. So you plus 0. Then we only have this one, 191 over 256. And for variance 2x plus 3, for the constant 2 over here, we take it outside and square it. So you have 2 square from here. 2, you take it outside and square it. 2 square, multiply it with the variance of x. And the 3 over here, you don't have to, we just ignore the 3 over here, since variance of any numbers or any constant, you will get 0. So 2 square times variance of x. 2 square is equal to 4 and variance of x is this. Then you get these numbers or this value. And the variance of 5 minus 8x. And remember again, variance 5, you will get 0 because this is any constant or on real number. So you get variance 5 equal to 0 plus variance of negative x. So variance of negative x, the negative 8, the negative 8 over here, you take it outside and then you square it, then you multiply it with the variance. So you have 64 times 191 over 64. 191 over 259. This is the variance. So this is the value you get. Okay, that's all about expectation and variance of random variables. First, you need to know that expectation is actually equal to mean of x, and we need to find expectation in order to find the variance of x. So with this, I end our flipped classroom. Thank you for watching.